All right, good. I think I'm almost there now. If I can, now I should be able to get to your guys' screens. Yeah, okay. Program's working. Excellent. Good. Oh, that's the only one I have. Let me open up a new one. Let's see. I have my PDFs for that for these assignments. I'm just gonna pull up my PDFs for GD&T problems one through at least a few. I can't get through them all, and then the ones I don't get through, I'll just push them to next week. Um, So I'll see how many. I'm just going to open up my PDFs, and I've attached a PDF where you have that image. That's the first one I'm going to do, and then I'll open up a few of them and see how far I can get, and if I can, I'll get further. There's a shaft one, and then there's this angled block, but I'm going to start with this one. Okay. So I'm just going to quickly just model this and put these essentially as they are dimensioned here. Yeah, so I've got a block that's what, 4.5 by 3. It's 3/4 inch thick. And then I've got this little hole pattern. So I'm going to throw this up on my other screen. And that's for problem one. I think all of these are in inches, I think. I don't think I use a metric. So yeah, that's the same image that I just opened. It's just that one. And that's what we're going to draw. So let me just jump in here and just open up a new, sorry, I'll open up a new standard part here, just standard. I'm not going to put any material on this. It's okay if I just leave it generic. It's more of just a GD&T study. So I will get it so that it's front plane. This will be my front view, so I'm going to design it that way. And then I'll just pull a right side view like this. It could be arguable that maybe you'd pull a section down through these holes for this side over here, but I think I'll just keep a standard right side view. Yeah. And most of my GD&T, but I'm gonna when I look at this, there's a few things, and maybe this wouldn't stand out to you unless you're an expert in your chapter already. But one of the main things that caught my eye from, if so I like this as almost assignment where somebody's done this, but I need to refine it. I only have slightly better GD&T skills than the person that did this last year, which was me. But some things I don't like, what caught my eye right away is datum A is hooked to a dimension. And this then should be interpreted that datum A is a center line or a an axis of symmetry or even a plane. And I could have just misspoke there. So yeah, there may be I may misspeak a little bit. Whether that can resemble a plane or not is what kind of I crossed my mind. I was like, I don't know if even if I line up with the dimension, it's definitely for an axis of symmetry or a datum axis. When I line the datum up with the dimension like this, arrow to datum foot here. So this caught my eye right off the bat because I think what I was trying to do is have datum A just be the bottom surface. And this is all just datum surfaces on this. And so it does have three datums. A, B, and C have been identified. I just don't love the other thing I don't love is these datums hooked to that feature control frame because that also, I think, to me, in my little study means I might be talking about a circular. I'd have to check this. So I'm gonna do a couple things. I'm definitely gonna move datum A to make sure that it clearly shows that it's a surface datum, like what the front side is sitting on that bottom surface. Datum B, I'm going to clearly show that it's going to be the same surface, but I want it to be the actual front surface right here. And datum C, I want to be this left side surface. And so I'm going to make that a little clearer. I'm going to drop these are controls here for how flat datum this surface would be. It's not really controlling the datum. We just happen to be using that flat, if that surface has been flattened, we're going to use that as datum A. You don't hook those together. These are standalone. I think in a lot of the form commands or symbols you'll see, they can stand alone from a datum. They don't necessarily have to be hooked to a datum. I'm going to drop this because I think there's too much. This is too busy of a first GD&T of what's going on to me. So I'm going to drop these and I'll add them maybe on the third. I think the third assignment has some of this going on, and I'll pick it up there and talk about it. What also stood out to me is just some of the drastic difference in tolerances that I have here. Even if I was going to use them, this is a 10th tolerance on a flatness. That might be a little coarse, unless it's a real, I don't know. It seems quite coarse to control that at 10. uh, or 1/10. These seem to be too fine of a hold to me, like 2 thousandths on a flatness and 2 thousandths on perpendicularity might be. It seems to me that's ultra fine and ultra hard. Maybe we're asking a lot of a machinist there, and so maybe it'd be close. Maybe those would be better if they're like 10 thousandths for. If I think of these as kind of like general parts and not that I know their specific how highly accurate of part they are. So I want to keep this as kind of just a general part. So I think this gives you a little bit of a misunderstanding of this is a really tight tolerance on flatness. I think we could open that up if we were going to use that. I'm just going to drop those on this. So I'm not going to use these flatness and perpendicular geometric constraints. I'm just going to establish those datums. I'm really going to focus on the holes. And I'm even going to simplify the holes a little bit, and then I'm not going to make this a little bit more of a compound control on the center hole. I'm just going to use the position. Really, I just want to explore a position GD&T uh, feature control frame and control. So I'm going to use the dimensions. The dimensions are fine. You can see some of them have been boxed. That is a theoretically exact dimension. We usually, the way we model, when we're dealing with drawings a lot or sketches, we're probably drawing what is theoretically exact, and we model kind of to that theoretically exact. The reality is GD&T exposes you to this world of no perfection exists, right? We actually cannot make, especially at a microscopic level as we zoom into stuff and some of the exaggerated views that you've looked at in the chapter, if you've gone through your questions, they show like things that are really out of cylindrical shape or and they over exaggerate how those the deformity that we would see in parts. It really is probably almost imperceptible to your human hand or touch, some of the imperfections that will cause part rejection. Really has to be done with some pretty highly technical equipment to evaluate if things are made in tolerance or did they fall out of tolerance. So anyway, I just want to keep this one a little more basic than it is. But these are basic dimensions. I'm really going to use these just to not all of them are basic, only the ones that are really driving a control. But I would argue on that. I'd have to look through these dimensions and say, okay, if it's a basic dimension, it should be coming from a datum, and it should be used to locate a feature of size. And so I'd have to look through here and say, are all the ones that are basic dimensions? Yeah, I think so. I think the basic dimensions have been identified correctly here. And so so the only thing I'm really dropping is I'm just really gonna make sure my datum is not confusing which surfaces I've chose as datums, and I'm going to drop the controls on those surfaces. And I'm going to say they're just more of a general, I'm not really controlling how flat that is. Maybe my part is not that critical. And I'll open up some of these tolerances if I were to use them. So let's go on, and that's my spiel on that. So those are just the things I notice when I come back into this next year. I'm like, this has got some revisions to do. So let's try to work those in this time. If you look through my stuff and you find these 5 problems, if you find stuff after your reading that you're like, I don't think that one's correct, I would appreciate that feedback because more eyes on this is better. And if you can't interpret those, that's okay. It just takes a bunch of study, I think, and I'm just barely scratching the surface of it myself. So let's go ahead and design this thing. I'm going to put it on the XY plane in its rectangular look here. So I'm just going to jump in here and say that this is what, 4.5? Is that what it is? Yeah, 4.5 by 3 is my block. I'm going to constrain this into the origin point. I'm going to constrain it symmetrically over the origin point here when I do this. There's my part. And I'm going to go ahead and do all the holes in this. So I'll just draw these as circles. So I think I will put one circle in here that is these are 5.625, so 0.5625 in diameter. That's 9/16. And then I will dimension one of these. I think I'll actually dimension this one maybe and pattern this. It wouldn't really matter. I'm just looking at what dimensions I have to work with for my drawing. I'm given this dimension here as 0.563. I'm going to put it in just like that on my drawing. 0.563. Technically, that's probably 5.625, 9/16, but I'm gonna just put it in as it is on the drawing. We're gonna let the position control this. it's like this drawing has been held to 3 decimal places. Everything is really 3 decimal places, so I'm just going to keep that standard. Um, let's see. So, and then it's over 3/4, I think, but it's really from the other direction the way it's dimensioned. It's like, so I'm gonna kind of do that. What I'm looking at is I'm actually using this dimension to place it, and then I'm going to use this dimension. It's really 3/4 and 3, so I'm going to say it's 3 3/4 from this edge over to there. So I'm slightly using. It really what matters you model technically, as long as you get the right dimensions in there of what the whole pattern should be. But if I'm looking at that drawing, it's kind of from here to here is that 3, which is what will constrain this 3.75. I'm just going to pattern this kind of up I'm going to pattern this as yeah, I'm just going to use pattern, rectangular pattern. You could have done this a bunch of different ways, but this way will work. So I'm just going to pick a direction for my pattern. Really, I can pick geometry. So maybe I'll take this. I think the center points won't come unless you bring them over, and maybe I'll bring that and the center point over. And the direction, I'm going to go this way. That's actually the direction I want to go. If it wasn't, just reverse it with the black arrow. And these are 3 inches apart. So 3. And then the other direction, and what I did is I selected a line in my drawing to pick direction, right? You could select an axis, you could drop down origin and select an axis for direction. I'm just going to select some of my sketching elements there. That's going the wrong way, so I'm going to flip it. And then this spacing is 2, and it is 1 and 1.875, so 1 7/8. So there's that, and then I have one big circle in the center, I believe. It's kind of 2 1/4. Let's see. This whole big rectangle. Yeah, it's 3 inch by 1 7/8. Yeah, this is 1.875 by 3 inch is kind of the pattern. I mean, you could do this a lot of different ways. You could have just, I could use like a construction rectangle of that size, and then the endpoints, I could use the whole command on the 3D tab once I exit the sketch. I'm just putting all of it in this one sketch here. So it looks like this. This hole right on center is 1.5 in diameter. And I just snapped it to the origin point, so it's already constrained there. And that's a finished sketch. To ever edit those patterns, right, you kind of have to select it and look for this little pattern symbol that kind of matches what's on the icon in the yeah, just usually you can select an element and then you would select this almost like it's a constraint and go in and say edit pattern. Should be able to say edit pattern. Let me see. Maybe I have to hold, yeah, I think edit pattern right here. It seems like I have to, I don't know. And it went right away. Yes. Oh yeah, yeah. I don't even, I'm like left clicking then right clicking, and that's causing my issue. Just hover over it, right click, and you'll get to your pattern. Yeah, it's either yeah, so confusing on whether you gotta actually select it or just hover over it and select it. Try always both in every situation. This is 3/4 of an inch thick, so I'm going to extrude this thing and then be done with the modeling of it. I'll just extrude it. It doesn't matter which way in my case, just that it is 3/4. Okay. I'm going to place this on a draw. I'll go ahead and save this as my week 6 in class. I'll call it problem 1 in class. I'm going to put it on a drawing right now, and I'm just going to dimension it like we would normally. So first thing I'm going to do is just kind of put my, like to me, even if I'm going to go into GD&T land, I might still just perform my initial drafting on it before I worry about how I'm going to control things. So I'm just going to open up my template to put this on an inch template. Okay. So let me think. And then inch template. Yep, yep. And I'll go ahead and save this one, file save as, so I don't mess up my template as that same problem, but in class for me. So I got my part, got my drawing. I'm going to drop my base view. Should be my front view. I think 1-to-1 fits well on this too. And I'm just going to drop a right side view. It's because the other ones were done in CAD that there wasn't an isometric view. So I can go ahead and drop an isometric view of this. That'd be great. So that's another addition that I can do pretty quickly. And And I can size that down later if I decide I want it a little bit smaller. So yeah, I just need all my, I need my center lines, need my center marks. I'm going to drop some center marks here. There's some center lines on the side here. I'm just going to kind of pay attention here. Uh, Looks like the upper hole. I've got two hidden lines here, right? So the lower hidden line is the actual hole that I want to add this to. Well, kind of. That's my cross center line, this one. And to me, it's this hole. And then I'm going to do one more that's really this whole side center line. I think that's this one and this one. Yeah. So I've got my center lines. I'm going to pull them in. When I have a grid pattern like this, I'm just going to pull them into center, get them to overlap. Just kind of doing a quick down and dirty. We're gonna run this. I'm gonna run this. We could definitely set up some dimension styles and help us do this. Three decimal. I'm just gonna run it pretty manual, almost like I'm dimensioning with CAD in some ways. Although sometimes CAD's dimension styles are. I mean, they're just as easy to build here too. But they'll have a two-dimension decimal style. But I can drop one dimension, then I can just like copy the properties and or I can drop them all and then change one and copy all the properties. So I might just kind of do it manual like that. But what I want to do is just get its overall dimensions like we would anything, right? Like look at the thing first. It definitely needs some overall dimensions here. I'm going to pull this one down a little bit in a way. In fact, I'm going to make myself just some room. So I'm gonna have to like adjust these at the end, almost like I'm in CAD, because I just don't know how many dimensions. I think I'm going to dimension the height over here on mine though this time. I don't have a lot going on the right side view, and I think I don't like that it's, to me, it's also breaking even some of the drafting 101 rules in ASME, which is if you have multi-views, drop your dimensions in between views. So this 3 inches, I'm just moving to be in between views. This 1.5 inches, I'm going to try to move to be in between views. So I'm really going to pull these left side dimensions back in between and not going to worry about tolerancing them yet here or doing anything. Just get them snapped on there. So I've got that one, that one. Then I need an overall width, right? So maybe this is a great place to grab a width. Just pay attention whether you're grabbing endpoints or lines and make it intentional which one you're really trying to do. That's overall dimensions. And then we would proceed to just as we were normally drafting, we would proceed to size and location and size for the features. So I think I chose, this hole up here. If I choose hole, it's going to give me a depth, so I'm just going to use a dimension. And so this dimension here is the hole dimension. I'm going to increase its precision here in just a minute, but there's really 4 of those. I could add that in there while I'm in there, at least in the text box in front of the dimension. I'll add that it's 4x. Because you can actually start this and you can add the feature control frame for the GD&T symbols and tolerance after a dimension has been placed. So it doesn't have to be part of that. So I've got that size. There's 4 of those size. I just need to locate them. So the dimensions, I like where they use the dimensions. They chose here to here to locate kind of how far up that is. And then they chose between the two. And so this seems like a rule breaker. This is what we'd call as a chain dimension right here. These two are going to be chained together. And we'll talk about why GD&T will allow you to either do baseline or or chain dimensioning. It's because of the theoretical exact when we establish basic dimensions, then we're just saying there is no problem with that dimension at all. Working from that dimension is no problem because it's a theoretically exact dimension. And so you can chain dimension, which is seemingly weird because it seems like it's the most inaccurate kind of dimensioning, only it's not in GD&T when the chains are basic dimensions. They're actually theoretically exact, so there would be no error in them if you could get it that accurate. Actually making it that accurate. And the other option I would have, right, is always GD&T will still allow you to do a baseline dimension, which would be this dimension for that next feature, right? Like this, you would see me do more of this in AutoCAD. Like I would kind of avoid this only because we weren't doing any GD&T, and really my drawings had a tolerance applied to them because we have a tolerance block, which we're gonna dive into the weeds on that today too. So there was a tolerance applied, and so chain dimensioning with a tolerance applied is where you can get tolerance stack up, and if one is off, And even with it's in its own tolerance, it'll affect the other's position based off its tolerance. And the more and more features you would chain dimension with a plus minus kind of tolerance, you would get it. Technically, you may get a position that is out of that is not correct because all these tolerances have stacked up, and the thing and now that feature of size is way off course. So, but with basic dimensions, we're saying there that is not. We're kind of overriding it, overriding the tolerance that's applied on the sheet essentially. And we're saying, no, don't apply tolerance to this at all. This is a theoretically exact size. Um, so I can chain dimension this for this. I don't need both, but I'm showing you this is baseline dimensioning. This would be chain dimensioning, right? These are good. These are good drafting 101 reminders. So I'm going to leave it like that. And then I just need to dimension the other ones. Let's see, I've only dimensioned them in kind of the Y area. I need the X kind of location dimensions. So on our print, it pulled it from here. And the reason why they're going to pull it from here is because I'm going to establish a datum to pull it from. So this is one that they snapped on there. You know, you would think, oh, I'm going to pull from here to here, and you'd be right as long as you establish a datum to locate that. And then here's the other chain dimension that they slapped on ours. Those two parts together. And then I just need the location for the other hole here. So let me just do its X and Y. So I think I can drop this one in just from here to here and probably in between these. I'm probably going to bundle them over here and kind of fix these. Is that what, I don't know, maybe that's not where I am going to crisscross if I do that, huh? Yeah. I could have pulled that one over here. I'm pulling from the same datum. So the only thing is, I think the reason why isn't this one on my other drawing pulled probably from here. Probably for that reason, just to get it clarified. Yeah, and I'm going to pull the center line out to the object edge though. I know that was easier to see in CAD, but here I'm just going to try to pull the center line to the object edge and let my dimension go to it. It does create a little gap here. Usually, maybe an ASME standard it would be okay to have those overlap each other and not to show a space off. But when I pull that out, it's going to kind of snap my dimension off, which I'm okay with that. So I think I'm going to use that one, and I'll just drop one down here in the lower right here. And I just haven't sized that, but I've located it, so I should have sized it first. But yes, size of that hole, let's put it like we would in a normal drawing. There it is, 1.5 inches. Go ahead and drop that. There's only one of those. So really, I mean, with a little cleanup here, I would dang near be done on our normal drafting, right? And we would think like, yep, go ahead and make this good. So now we got to make this way overcomplicated. But in some ways, it's less color. Okay, well, this is where I'm going to discuss a little bit and put some of you to sleep, but just hang with me here. Okay. So what we don't always think about when we have this is this mighty powerful tolerance block that lives on our drawing. So this means that anything that is held to these certain decimal places, I'm actually to infer that this is the tolerance. So and I'm so I'm not 3 decimal places yet. So let's go ahead and kick that up because technically if I'm maybe I worked with engineering and that's that other I'm making a revision to that other drawing, it was all held to 3 decimal places. So I don't want to decrease accuracy. I also don't want to increase accuracy from it. So let's just do 3 decimal places. So I'll just change one here, which you can just go in here and you can do it and double click because here's your precision and tolerance tab right after your text. This is really manual, but I could totally build a dimension style to do what I'm going to do now. I just feel like I'm just going to run it really manual here. And so all I want to do is kick the primary unit to 3 decimal places. And then I'm just going to go ahead and kick the primary tolerance to 3 decimal places too, because when you have a 3 decimal place in inches, generally if we ever display a tolerance, we'll hold the same amount of decimal places in our tolerance than we would our specific dimension, right? So it wouldn't make sense if I ever do apply a tolerance to this to have it as 2 decimal places. So I'm just going to go ahead and bump these up. So they're both 3 decimal places, even though I don't have a tolerance showing yet. And then, and at least I'll do that. So let me go through and get all my dimensions to 3 decimal places. So all I can do is just right click on this now. Maybe I have to left click first and then right click. I get a bigger menu. Nope. I can copy properties. I know I can, I promise. There it is. It's just a hover over right click and copy properties. It's kind of my match properties. Why they don't call it match properties, I don't know. But now it's just I can go ahead and click all these and kick them out to 3 decimal places. which is still a lazy way. Oh, it did override that though, so I'm gonna have to come back in here and say, hey, I still want four of those. It did some attributes of it, copy properties will not, it'll still mess you up a little bit. So 4x of those. Everything's at three decimal place now. Okay, cool. Well, now that's one step. We're at least holding the accuracy from the original drawing. The next step is let's look at what this means then. So that means that if someone is going to locate, I'm going to start with this four-hole pattern and just talk about it. Like really, yeah, we would think we're done, but if we want to control this hole pattern way more carefully, let's do this. We can control it with the existing tolerances here. And so let's take a look at what that looks like. And what that looks like is there's an existing tolerance because I have a tolerance block on my drawing. And if I didn't have a tolerance block on my drawing, I should throw that drawing away and be like, I can't even build to that, right? Like that would be it's actually one of these things that you get over, you get so used to seeing that you ignore it. But if you ever issued a drawing that didn't have a tolerance block, you shouldn't even like, it shouldn't even be, it should be thrown in the garbage. It would be a major revision because it's like, hey, it shows us that we can't draw things perfectly or even create them perfectly. So this is our tolerance that's acceptable. And it's 5 thousandths at three decimal places. That's 5 thousandths. So what I can do here is what that would look like really I mean, this captures you so you don't have to do all this, what I'm going to do. But if you were really to look at the dimension as it could be interpreted by someone to build this, it would look like this. If I go into the single dimension, so let's think about I'm thinking of the location first of these holes, and we'll deal with size next. Even though when I say size and location, I usually size and locate first. Let's just look at location. So location to me says that this dimension, yeah, it's three decimal places, but really, if I go into my precision and tolerance, if I wanted to display what my tolerance block is telling me down below, it would look like this. It's a symmetric tolerance. It's a plus or minus and it's plus or minus 5 thousandths, right? Yes, 0.005. So I'm going to add that as the upper value right here. I think with a symmetric one, it only gives you one place to put in the tolerance because it's the same. It's not an upper and lower. You have to have a deviation in order to put two different inputs in, which is that kind of tolerant, like kind of think of these as dimension styles for sure. So that's the only thing I'm changing, symmetric, and I'm adding that, and this is what it would look like, right? This is me actually kind of showing what's inferred by the tolerance block. That it's 563 plus or minus 5 thousandths. Okay, that's great. So what does that look like then? Like what if I'm going to drill that hole in that plate? What is that going to tell me? Well, it's going to tell me that it can be off a little bit, right? From this, if I pull my dimension from this bottom surface to there, I can be off like really what, 10 thousandths kind of. And so what this looks like is I'm going to go back here and draw this. And you can do this too. It's a good exercise. And you see a lot of videos when you watch GD&T on YouTube videos, which I haven't totally dedicated my life to that, but I did find some new ones too. I did post one in this week that is really killer on this exact concept. Which if I could get anybody just to understand one thing of, if I could, this would be my only goal, really. If it was my only goal to get you to understand this concept in GD&T, I would feel like a success. Because what we're gonna explore is why Dakota said if you could just GD&T it, you can get rid of the plus and minus tolerancing, and we're gonna explore why that is right now. Well, so let's go back to my part. Here's my little happy part. Hey, this is Bob Ross. Here's my happy part. I'm gonna do a sketch on this front. This is not a sketch that I'm gonna do anything with. The part's done, but I'm going to explore what tolerance looks like on this part. So I'm gonna do a new sketch just on this front surface right here. So what we have is this is our hole that we located with the dimensions I was given on my drawing. So to me, it's in the right place. But so I'm just gonna project this geometry of this lower hole that I'm talking about. There's its center point. I can even dimension this, right? So maybe I'll project this other geometry. So, because we're going to look at this location in two different directions, right? It's going to come up from here and then it's got to come over from somewhere else. It's got to have kind of an XY coordinate to locate it. So I'll just start with this kind of in the Y direction. Let's talk about the tolerance in the Y direction. Well, and in the X direction a little bit, but so if I dimension this, it's really it's going to say, hey, this is a driven dimension, right? It's going to call it a reference dimension because it says I'm really not moving that at all. So I accept this. So that's our dimension that we dimension out. That's what shows up on my print. It also is plus or minus 5 thousandths. So really what that looks like is the plus or minus 5 thousandths is really the center locating of that hole where I'm dimensioning to. So what that looks like if I zoom in here to the center point and I build a rectangle So I'm just building a rectangle that is really the tolerance limits. So when we see a stacked dimension that's plus or minus 5 thousandths, yes, that's a symmetric dimension. It's but really the limit of that dimension is from its lower value to its upper value, right? That's the limits of a tolerance, I should say. So really that tells me the part could be, and I'm just thinking of my dimension, it's 0.563, and it can be this big. It could be minus 0.005. So the dimension would be acceptable if it was 0.558, because that is minus 5 thousandths from the dimension that I'm given on my drawing, using my tolerance implied for my tolerance block. It could also be 0.563 plus 0.005. So it could be as big as 5.68, or it could be located that it's not as big as, but it could be located at that dimension and be within what I call the general tolerance block on the drawings specs. So really what we have is a limit from zero, those two, if we add those two up, the lower limit plus the upper limit, we get a 10 thousandths um, tolerance kind of envelope where I guess I don't know if that's the correct term, but definitely there's just like where the tolerance lives, the limits of the tolerance is 10 thousandths from low to high. And the way I modeled it was right smack in the middle of those. So what I'm trying to say here is what the tolerance zone looks like is a square rectangular tolerance zone, because this little center of this circle can live in this little square that I'm going to draw. That is, if I just snap it here, I'll dimension it now. It's the tolerance limits that I'm kind of dimensioning here, which is I'm going to double click in here so I can enter a dimension, which is 0.010. It's 10 thousandths. So I can be off 10 thousandths in that y. This is in the x direction on my drawing, essentially. I can be off 10 thousandths as long as my center point of my hole is in this little 10 thousandths window, it's good. And the same way this way too. So I'm going to say, yeah, that's the dimension I want. And then this direction is going to be the same. It's the same in both directions. So if I'm going to enter this, I'm just going to pick this dimension right here, maybe if it's not hiding over, there it is. So really the tolerance like little window looks like this. I'm going to drag this over kind of closer to my over to my hole, and I'll center it over this hole probably. I'm going to use my same kind of constraints as almost if this was like an origin point. This is center of my feature of size, the hole. And so if I pick this line here, I'm just lining it up there, and then I'm gonna do a vertical constraint. So it's here to here. Here's my little tolerance, like little envelope that my part center, my feature of size center can live in. So I'm saying on my drawing, if I'm the person that has to actually put the hole in this plate, you as a drafter have told me, okay, as long as I hit the center point in this little square, it's an acceptable part. If my center point falls outside of that square, it is a rejectable part. And so I build this little unusual square to have to fit my center point in. And so let me see where I want to go from here. And so that's kind of a restricted and so let me look at this. I'm going to make a circle, and I'm going to snap it to that center point here. And this is going to be really, I'm redrawing that yellow circle. This is a 0.5625, a 9/16 circle. I shouldn't have snapped it to that center point actually. So I want to remove that constraint. Let me just undo that and not snap it to that. Sorry. One more circle. Just kind of put it arbitrary here, but it's going to be 0.5625. Now I might constrain this to nothing. I'm just going to bring this in here. This is my center of this is me showing that I could technically to match my drawing standard that I currently have. This little circle could be anywhere that I would move this little center point. It could even be on this probably. It could likely like snap it to one of those lines. Like I could go anywhere in here would be where my part could actually live. So it can kind of look like this. I mean, those definitely, this is how I've modeled it. This is what my tolerancers are saying that I would be okay if my circle lived where that purple circle is right now, because it's in my tolerance zone. The center of it lives in the tolerance zone. Even if it lies on that, it's going to still be within the tolerance zone. So really you get this variation of where this hole can really live when somebody's putting it in, in a manual drill press, if they're just going to manually drill it, or if it's going to be in a machine. He's got the operator has all of this tolerance to work with. Well, it's not a lot actually. It's actually kind of limited, and it's an unusual shape to have a square tolerance zone around a round feature for sure. And so the furthest it could get away from where my theoretically exact point, like how I've modeled mine, that's a yellow point there. The furthest I can get away from that is really probably this corner out here, way over here to this corner. In fact, once I snap it there, it probably goes. But this would still be within tolerance, even though you can see how much variation it could really have as it goes through that plate. So my point of saying that is if we take the same tolerance, but we make it cylindrical or round in shape, we actually increase. This is what'll blow your mind and blows my mind. If we just say, okay, well, what is this dimension? Is if I view this dimension as a radius of a circle, so that I have kind of a diameter across the diamond of this like express tolerance zone. How big, what does that circle look like? So if I could make a circle with this kind of this, and what I'm doing is picking the furthest point out on the rectangular tolerance, which would be the corner. All of these would be kind of closer to this center point. But way out here on this very corner of this rectangular tolerance zone is about how far away I can get from my center. So if I snap a little circle here from the center to that little corner, that's going to be a tolerance zone that is circular. And if I use so and GD&T can allow us to say, hey, locate that by with a circular tolerance zone, not a rectangular tolerance zone, and we'll still call it within spec. And it's really still picking up the same distance out from center as as this one that was an acceptable. This is an acceptable location for that circle to live in. So also all of these around the circumference of the same tolerance zone, only circular, actually are all also would be within the same, they would be an acceptable part. Because if this is acceptable from this far out, then this is absolutely acceptable around this. So, engineers and designers or somebody decided long ago that this is a far superior tolerance zone because I have a round feature for one. Round and round make a lot more sense. And this increases your tolerance zone by a mind-blowing 54%. So now if whoever has to put this hole in there, if they're able, you're holding them to a tighter tolerance to use a rectangular coordinate plus and minus type dimensioning. You're giving them actually the ability to be sloppier, which sounds scary, but you're just actually giving them we're giving ourselves more parts that are acceptable. Maybe, yeah, and it's 54% more tolerance zone if you added up all the square. I think in my little video that I posted in the resources for this week, I think he just shows you just do, the difference of the area of a length times width here versus the pi times r squared for the pi times diameter. Sorry, is that no pi times r squared for the I should know this, I teach math. But yeah, this increases by 54%. It's in your book too on page 449. I highlighted it in my book because it said, in comparison to conventional methods, the use of positional tolerancing. This is I'm using a positional tolerance GD&T concept here. Provides some of the greatest advantages to mass production. The conventional coordinate dimensioning system limits the actual location of features to a rectangular tolerance zone. Using positional tolerancing, the location tolerance zone changes to a cylindrical shape, round shape even, thus increasing the possible location of the feature by about 54%. It's right smack. It's kind of on the left-hand side of 449, right in the middle. I mean, if I could only, that is where, like, if I just focus on pull one thing out of GD&T and drafting, it would be this concept of locating a hole with a GD&T positional tolerance increases the acceptability of your part, right? Because now things like if they put stuff that was out in here and it was a rectangular tolerance zone, it's essentially it's a rejectable part. It doesn't hit my tolerance zone rectangle, so I'd reject it. However, if I make my tolerance zone round, I get so many more acceptable parts. And so that is my study of that. Oh, other than I can like break this. Now if I take my little outside circle, I'll just delete it and draw a new one that's Oh yeah, this is on page 449. And it's like under location tolerancing, uh, right in the middle. It's like the second or the third paragraph under location tolerancing. It says, in comparison to conventional, it starts that paragraph starts with in comparison to conventional methods. And I just read about the first half of that paragraph. But that is why Dakota said, this is the whole reason why Dakota said, oh, this is where I would want to use this. It creates more acceptable parts for me. It actually decreases it's slightly, yeah, it makes it so we can be a little sloppier with our locating of this hole and still be acceptable. Because here's my point 5625 dimensioned circle. And if I actually snap it, maybe I'll just snap it to this circle now here. I'm just going to pull this in and put it on. Well, I'll just do a coincident constraint. Coincident constraint this to this. And now this is how much sloppier my whole location can kind of get if I kind of like if I move out and kind of roll it around this radius. This is really where I'm now with positional tolerance. If I'm going to change that from just being a plus and minus tolerancing to this, I get a lot more whole variation of location, which might to you guys seem like that seems like that would be an inaccurate part. The actual it still is an acceptable part. So yeah, it's really interesting to me to see how much variation you actually pick up. So that's all I did is I did that brief little sketch. I'm really picking it up in both directions, right? That's because yes, I'm currently dimensioned kind of an XY coordinate dimension. So all I want to do is show that, and then now we're going to go say, okay, well let's apply that to our drawing to take advantage of that opportunity that exists in GD&T. So what that looks like is go back to my drawing. That looks like I can start to and so what they'll do is they'll say, well, in order to use that, you're gonna get rid of first thing you're gonna do is get rid of the plus and minus tolerancing. You don't want to do like a tolerance on a tolerance here. And so they say that, okay, so now I've got to protect my dimension from being like tolerance with the general tolerance block. And I feel like a basic dimension builds a fence around it to protect it from the application of, I mean, that's just my own little concept, right? I'm gonna box that dimension in to protect it from the tolerance block and what's going to happen to it if I don't. So I'm actually going to come in here instead of making these all plus minus tolerances, which is what you're saying here. Let's control that and say that's not sufficient here. We can accept more parts. So I'm going to select here and just turn this into a basic dimension. And now I'm protecting it from the tolerance on the sheet, and I can now use it as a location dimension for where this hole lives on this other plate here. That's what the box means. It's a theoretically exact. It's how we draft and draw in solid model generally, is we're using those theoretically exact dimensions. But that's a higher standard than we can hold manufacturing to. And so they created this system that's like, okay, now let's deal with reality and that things are not made perfect. And actually they just cannot be made perfect. So we have to develop a way to say what's acceptable still and what will still work and still do its function and have its interchangeable, they call it interchangeability in our chapter a lot. I think of it as functionality more. It'll function as it's designed. So yeah. Now, in order to use basic dimensions, you should establish datums. So yes, I'm going to start to change some of these to basic dimensions, and then I'm going to kind of think about the size of this hole. I've only kind of been thinking about location, but so in order to do this, I'm going to go ahead and establish the datums that are on my drawing, which is in the annotate tab here. I'm just looking for this datum feature symbol right here, right? I wish they call it a datum feature symbol like our book, but datum identifier symbol. Okay. Maybe it's a more correct term. So I just select that. My first datum in this is going to be a surface. So surface datums have to be established correctly. You have to put them on the right, there's certain ways you can do that. And that is given on your page. We kind of talked about this even last week a little bit. I flew over this page. I told you I was going to get in the weeds just a little bit, but I'm trying to stay high level weeds. High level weeds. Medium cuts. I don't want to go too. I just want to do a couple things. But this is on page 414. 414 in your book shows the way you can apply a datum feature symbol in order to be to show clearly that your datum is a surface and not like a hole or a center line or a center plane. Like these are designed, and so this is really specific. This is when I caught datum A on my other drawing. I'm like, that looks like it's a flipping hook to the dimension and it's too close. It could be interpreted as an axis. So I'm going to say no. I'm just going to select here. So I'm in my datum. I'm in my datum feature symbol. I'm going to select this thing here. And I think it's kind of weird, like normal leader lines are, but it's movable after you apply it. So I know it looks like it maybe turns 90 on you. I think I can just double click this thing. I'll just say, okay, I'm gonna keep my first one as A. And so then I can just drag this like this and like adjust this in like this here. So yes. So and I'm just going to kind of keep it, keep it compact and tight. But this is to me, unless I don't have a reason to hook it to the surface, I think I would hook it to the surface. If I have room for it on my drawing, this is the most clear, it's clearly just hooked to a surface. So this is a way to say that that bottom surface in that front view is a datum. That I'm going to then and the reason why I'm going to establish this is I'm going to pull dimensions from it. So I'm going to kind of lock it down and say, oh, I'm going to hold this thing, as true as I can. The other print shows I'm going to apply some flatness control there, but I'm not going to here. I'm just going to keep it really simple. I'm just going to call it a datum. I'm not even in control any of its geometric form at this point. I'm just going to really just focus on those locating of those holes as geometric. So I'm just going to say this is the datum. However, you could have hooked it here as long as you don't align with the arrow, right? That's a no-no unless you mean to hook it to the arrow, center that thing over the arrow. But it can hook to an extension line like this, and that implies that it is the surface as well. And there's just a whole bunch more, right? Yeah, I mean, there's even some for when you don't have a view that shows the surface, you can kind of use a dashed leader line with instead of an arrow. In your book, it shows that sometimes we terminate leader lines with a dot, and that dot termination on a leader line is means it's the surface that I'm calling out. So it's instead of an arrow where we usually point to, features and we point to edges. This one is with a dot on the end would be surface. So a leader line with a datum on it that has a solid line and a dot on the end, that would be still a surface datum that's towards me in my view. And if I kind of do a hidden line, um, leader line with a datum, that's a surface that's away from my view. And I would say I would try less to do that. A lot of this book and the way it talks is going to be some really complex, somebody that really knows GD&T. So for me, if I don't know much, I'm going to keep it simple and keep it clear. And I have nice room to just apply my datum A right there. And we talked about this a lot in CAD, but I thought, okay, but really once I do, and I'm in GD&T and I'm establishing these datums, then those should be where I pull dimensions from, especially locating dimensions. And so to me, now I've established A, this dimension is pulling from datum A. I've established datum A as my control point. This dimension comes from datum A up and locates this hole. And then we have those issues going on with what the tolerance for that would be. And then this one here is also going to be located it's like a chain dimension, but I'm saying that I'm holding this as theoretically exact. So don't worry about a tolerance that might throw this off. I can go ahead and chain dimension this now. But it needs to be basic. So I'm going to locate this hole. This is going to become a basic dimension to locate this elevation of these next holes here in the Y direction. And that's all great and dandy. I'm starting to get some locating dimensions for these two dialed in. I've got one datum established. In my drawing, it establishes, you know, not all parts need three datums. I think three is the magic number, and other parts can have more datums than that. So we're limited to maybe what letters we want to call different datums, but A, B, and C is a great start. And I think if you've used A, B, and C on one drawing, I think you can go to the next drawing and still use A, B, and C. I don't think you need a continuous kind of like that's different with section views and their view labels. I think we like to keep those kind of growing in the alphabet until I've gone through it all, and then I can start double doing the alphabet. I think this is something that I don't know. I'll do a little research, but I don't think you have to always on a different drawing with GD&T use a different alphabet if you're going to use GD&T and datums. I think just the part, exactly right. It's like I'd have to, yeah, to even be able to use it, I have to have that view to look at, and that's datum A, right? And if I go to my next part, it can have its own datum A, but I wouldn't really be referencing this datum A, right? It wouldn't even make sense to do that. So I think it's why we can overlap and use the same numbers from drawing to drawing. However, I wouldn't want the same letter to be used multiple times on my drawing. I don't want two datum A's. That's super confusing and not correct. But so this one's going to establish three. The difference is, and so what you think of is like locking down the degrees of freedom, which we when we build a part, we're kind of doing that, right? Like we when we see these origin planes show up, they kind of look to me like a datum feature simulator in some ways. They're three planes, and when we constrain our sketches or when we constrain our parts specifically in assemblies, we're kind of using the concept of locking down the degrees of freedom the part has. So you're kind of already working in a mindset of GD&T, like inventors just kind of built to like already use those concepts of my constraints are kind of like minimizing degrees of freedom of a part. And so anyway, and really, it usually takes three to totally lock it down, right? Once I constrain to a plane, yes, it locks it down, um, but it still opens the door to the part can still kind of rotate. And we could explore this on a part. I mean, you could spend your time like just doing a simple block, doing one constraint in an assembly on a plane, and you would see that I limit some rotational now by hooking it to a plane. But but it still will slide on other planes maybe, and so it takes like these constraints to these three different planes to really lock down its degrees of freedom. It's translational. I don't know if they call it translational and rotational, but that's also, I think, is a very important thing to note that just when you're dealing with parts and assemblies, you're kind of thinking of locking it down, uh, its degrees of freedom. So what I have and why I'm thinking of that is because I've kind of locked it down. This is data May. Now I'm kind of controlling this plane. So it's kind of like, this block, if I lock down this, it can still slide towards me and away from me, can still kind of rotate around an axis here, but it can't really go down. I mean, yeah, it can't I guess it can slide this way. It should be able to slide left and right. But once I lock this down, it can't go up and down anymore, right? That's true. It cannot go up and down the Y direction, but it can slide left and right in the X direction. So I'm gonna lock it down that way now, something that's perpendicular. So these datums generally the relationship they have between each other, it's especially these first three are they're gonna be perpendicular to each other to help control those degrees of freedom, so that this part could be evaluated and not move on it, not fall out of my however I'm going to inspect it. But so part B is going to be, I think, just the front surface here. And it's perpendicular to this surface, bottom surface enough, I think, of this front surface. And so you have some options, right? Like that. That even said I could actually do one here with a dot on a leader line. That would be that surface. Maybe this is the most clear. And for my GD&T 101, I might just say this is the surface that's datum B. So I'll go ahead and drop this one. I just need to change my datum to B, capital B. Someday I'll write it here. B, yes. I think I made that bold or something. Let me see what I did. I think maybe I did. Mine was bold. Yeah, it's kind of just like a word processing or Google Doc options there, it seems like. Yeah, so that's datum B. I mean, this thing could slide down here, right? This is a great way to display datum B as well. It's on the extension line, but not lined up with the dimension. That means surface datum. That means this front surface is my control B. And that means if I was ever to pull that, I mean, to me, that means that 0.75 dimension is pulling from that datum from kind of left to right. This is,
Keep telling him to like what should be done. The I don't know, the actual box itself to the line.
oh yeah,
Also,
because I think there's weird grip. I think it just takes a minute I think you can like grip this. I don't know,
well, like if you just get it too close,
like that maybe.
yeah, but
Oh yeah,
maybe you better.
it's just yeah. There's so many.
To do it.
Yeah, I
Seems kind of weird.
because yours looks weird. Like
Well, I know I think.
oh yeah, yeah,
Try.
yeah. I think it's just a matter of getting used to the double clicks when to place it. Because there are a lot of options to configure it how you want, right? Yes. It is kind of a little mini leader line. I'm just keeping mine kind of simple, but it could be hooked right to that. And then C is the last one we need, which is the other side right over here. This left side surface was what's kind of called out as datum C. So will drop that datum over there. So I think that's first I would kind of dimension out my drawings, kind of get a feel for which ones are going to be locating dimensions, what parts are gonna, which features of size am I going to control on a drawing? Here, I'm only looking to do the control on the holes, and so then your next step would be to know like which. Because to me, I have to know like which features of size I'm trying to control in order to kind of know which datums to establish, right? Because you have the option to select your datums, but they really need to be in relation to the location dimensions for features of size. So that they work together pretty well. That's why I would probably, as I entered the GD&T world, I'd say like, well, let me just dimension it with my normal CAD skills. Now let me identify which are locating dimensions for features of size, and now let me think, what are those best dimensions to pull? Now let's control where they're pulled from with datums. And so to me, that's kind of the thought process, is that's what's going to help me establish what datum. I think a lot of the time when we set up our part stability in a front view, we're thinking of a datum, and I've always kind of thought that way all through CAD actually. Is like, where am I pulling to and from? Am I pulling from more than three parts or more than three like planes or surfaces or axis or center planes? If I'm pulling from more than three of those, I would ask myself, why? Is it needed, or can I just move my dimensions to pull from, a primary, a secondary, and a tertiary like datum point? And in some cases, there may only be two that are required. So right here for these particular holes, I really feel like I'm going to control. I mean, it's definitely one that's a locating dimension in this direction. And then this datum over here, which is going to be C, this surface here, and I can move it where I want it to, but I'm just going to drop it in over here. This is going to be C. And one day I'll do capital C. Yes, good. And now I'm going to say, oh, okay, so I'm going to pull the location from A to there and there. And now I'm going to pull from C here to here for locating. And so I've kind of like done my coordinate locating dimensions, and I'm pulling from datums. It means that these two then are going to be basic dimensions because they are locating. So I'm just going to double click in here and say basic. Okay. And I'm going to say here basic. These are locating dimensions for those holes that I'm looking at. That's great. So now, and I've got three datums established. B, I'm not really, maybe not, I'm not inferring much from B, but I really am inferring by selecting datum B over here and how it kind of relates to these holes, is the whole axis is going to be perpendicular to that. And I think that's not something that I think it's just understood that if I establish a datum B that's perpendicular to the whole axis, then I know that my hole should, especially if when I build out this GD&T symbol for this, if I use B as one of the controlling datums, what I'm kind of inferring is that that hole will be perpendicular to B without even saying the perpendicular sign or whatever. It's just like, oh, when I build out the GD&T feature control frame for this size dimension now, I'm gonna put the datums that I want someone to pay attention to and to use as part of the locating and even the sizing parameters that I'm expressing through the GD&T symbol, which I haven't applied yet, just so you know. I'm just like almost getting there, and we probably should take a break before. I mean, yes, let's take a break, and then we will dive into finishing. I told you I was going to get in the weeds hard, and I'm going to, and we've got a little ways to go here still. We got to build out a feature control frame for this dimension. We've got to build out a feature control frame for this one. We just have to clean up our drawing and maybe change a few more dimensions to locating GD&T control dimensions basic. So we just have a little bit more work to do. We'll call it part one. Heck yeah. Take a break.